13. Good morning. It is good morning. Did you guys get snow up there?
No. Well, I mean, yes, but the hill's not, it's still 44. Yeah, it's nice and warm.
Salud.
Bless you. Oh, yeah, you can still get it. Oh, yeah. Yeah, it's not that much.
I don't want to put a trailer over the Lena if it's got snow.
Nah,
Sandra, that's what
but, you know.
my dad says that.
Perfect for hunting. You can still walk around, it's cold up, flush them out.
2 weeks and I won't figure out on it.
0.25.
It's really good. Yeah, it's not.
It's been like 15 degrees colder. Way colder right now.
All right, folks, let's jump into it. Just a couple of words on how the day's going to work before we get started. There's going to be a bunch of high schoolers in here later this afternoon, I believe, and they might come storming into the room around 2-ish. You just kind of ignore them if they come in. Additionally, if they do come in, I'm not going to be here. I've got a meeting across campus I got to go to at 2, so I'm leaving about 1:45 to make that, and I'll be gone pretty much the rest of the day. I'll come back after it, but I imagine most of you will be gone. So we got those things going on, and then this morning also there's a couple people that will be taking some tests. So if you would, try and keep it halfway moderate in here to let those people have their testing environment as we move through that. So you guys got anything going on for this Halloween thing? Is that happening pretty soon?
Tomorrow?
Yeah.
Okay, do you need class time for that, or what's going on with that?
We don't
Wait, what? I don't know about this.
Yeah, we had the coordinator.
It's been kind of blurry.
I know.
What we're doing.
Is it because the chief isn't here?
Yeah.
Yeah, I wasn't here, so you
Yeah,
guys.
we gotta get all that organized to do over there.
Okay, well, maybe we gotta have a little planning meeting on that this morning, so.
Okay.
Make sure we got that taken care of it.
Sounds
If we
good.
need to accommodate during class time, we need to know that, so.
Okay.
Plan accordingly, okay. Certainly, I think that's a good thing to get involved with.
Yeah. We get money.
I know I'll be back
What's that?
I know I'll be back tomorrow. Because I got to take a call.
Okay. All right, well, anything else? All right, let's jump into 13, chapter 13. In essence, what we're getting ready to do here is, and explain through chapters 13, 14, and 15, is really a summary of the work by Gaspard Monge. He got introduced back in the start. If you remember this gentleman, he was a Frenchman back, I think he actually was a general in Napoleon's army, but he did a lot of geometry and published all that data, and now we are the beneficiaries of his work, which there's some pretty good stuff in here. It solves a lot of geometric problems. 13 is really a standalone chapter and really doesn't introduce him. 14 and 15 do. I'm going to actually bring 14 in today. Now, when we look at 14 and 15, just so you know, we will not be doing those chapters in their entirety. We're going to pick and choose what we do out of those chapters.
I'll be 14 and 15.
Yes. Out of 13, we're going to do everything. 14 and 15, we will be kind of picking a little bit out of those because we don't need all that stuff in today's world. By now, you probably realized orthographic projection has a few holes in it as we try and project objects. Can anybody think of what's kind of the problem with orthographic projection? Because really, think of our mandate. Your mandate is you must physically describe the geometry of each object completely, and then we give the size of all our geometry, which is dimension. That's in essence what drafters do. We do those two things. As you try and describe the geometry, what kind of problems do you see with orthographic projection? see a lot of foreshortened surfaces, right? That we never really get to see. And when we talk about foreshortened surfaces, what type of surfaces are we talking about? Yeah, inclined and oblique. So certainly some holes there. Okay. Now keep in mind, what's the whole point of doing orthographic projection? It's to show true size and shape. And now here we have some planes, inclined and oblique, that show foreshortened, and there's no way to show them true size and shape. Okay, therefore, we've got to change a couple things. We've already changed one thing in that orthographic projection also doesn't show interior to objects. And we solved that with section views, correct? Now, what we're going to get ready to do is solve that inclined and oblique plane problem. But there's one other problem out there that you folks probably aren't aware of yet, and it's called a dihedral angle. We never see this true size and shape either. And before we go any further, let's define that, because we know the definition for an inclined plane, right? Edge view in one view, foreshortened in all adjacents. We know the definition for an oblique plane. Foreshortened in all views. Never see true size and shape, never see the edge. Now, what's a dihedral angle? We need to go to the end of the chapter to start this, and let's define a dihedral angle. It is shown on page 666, the page of the devil.
Devil
I
page.
was gonna say.
That's a good way to describe dihedral angles.
Persinate, Amy. I'm about to.
Here's a dihedral angle. In essence, a dihedral angle, all that means is it's an angle formed by the intersection of two planes. Now, the problem we have with dihedrals, they're not a problem if we can see them in orthographic projection, but many times they're like this one, where they come kind of at an angle to our normal planes. Therefore, you're never going to see this angle of cut. And so if a person's constructing this, how do they know what this angle is right here? Because they're going to have to set a machine up on that to cut it. And we can't describe it to them. Standard orthographic projection you see down here, none of these angles are going to be right. So therefore, we don't really know what that angle is, and we aren't telling them. We've got to be able to solve this one. They showed the solution of it over here. We've got to be able to do that also. So in essence, we're going to use the information in Chapter 13, auxiliary views, to solve the problem of inclined planes, oblique planes, and dihedral angles. That will solve those three description problems. So those are the three reasons we do this. Now as we come back to the start, if we're going to jump into a chapter that's called auxiliary views, I guess we ought to define auxiliary views. Did anybody pick up in the text what an auxiliary view is?
Other than 1/60.
That's pretty much it right there.
Wait, what did she say?
Did you say that about maybe?
It's an orthographic view that is projected onto a plane, any other plane except the one that, excuse me, onto any plane other than one of the 6 principal views.
Thank you. That's a good way to say it. Maybe to summarize that, just auxiliary views. Any view other than your standard 6. Any view other than your standard 6. I want to look on page 654, and we're going to compare and contrast figures 13.2 and 13.3. So I'm going to show both these here. So this is a pretty good example of what we do on auxiliary views. So in 13.2, we have our standard glass box. Is this glass box, by the way, is this real? No, it's not, right? It's imaginary plane between us and the object where we sit at infinity. Our line of sight is perpendicular to these sides. Okay? But it's an imaginary glass box that we put out to be able to produce these views. Okay? Now, if it's imaginary, do we have to stick with 6 sides on it?
No.
No, let's just start imagining other sides. We're not going to imagine them anywhere though. What we're going to do is we're going to come down to like 16.3 and we're going to imagine a side that is parallel to the plane in question. Okay. So that's in essence what we want to do. We're going to take this guy, we're going to put it parallel to our recognized plane, in this one instance an inclined plane. Now when you look at the views that are resulting, here's orthographic projection, Okay, we've got this inclined plane. I see edge here, but then it's foreshortened, foreshortened, foreshortened. Heck, where do I even see it here? Foreshortened, and then edge again. We never see it, even in 6 views. Okay. Now, if we look at the projection that comes off of this one, or 16.3, it's shown on the next page with the 4 figure, which is right here. Again, we've got all the geometry described. We got edge, foreshortened, foreshortened. But then here's that plane we took that we put parallel to our inclined plane. Again, we're going to unfold it, just like the glass box, put it here. Now I see that plane, true size and shape. So in essence, somebody has that information that they can now build that surface on this object. So in essence, that's what we're doing. Any questions or thoughts on this? Well, today we're going to take this and we're going to go through all the definitions of it. Tomorrow we're going to look at it and see how we do them. Let's go to page 656 and let's handle some more definitions here. When we are pulling auxiliary views, we have 3 types that we pull. And we want to know these terms because we need to communicate that to other people, other drafters, and say, hey, I want you to look at this view, we need to know the names. In essence, what this diagram here has, it doesn't make a lot of sense other than a definition. That's the only thing this is here for. Here's my front and top view. This to me looks kind of like a hip roof. You'd see this on a lot of houses. Okay. Now, they're not really turning this in the correct direction, but just keep in mind, these are our standard views. They have turned one auxiliary view right here. Okay, this is called your primary auxiliary view or just your auxiliary view when you're talking to somebody. What that means, it's always the first rotation off of a standard 6-view drawing. Okay. Primary auxiliary, first rotation off of a standard view. Okay. Now, when we take that one, if we're going to rotate it again, like to this view, now we've produced a second auxiliary view. We call that, of course, a secondary auxiliary. If we want to take that and rotate it again, we have a tertiary, or the third one. So in essence, when we take these objects, we have the geometry. We know from the rules of orthographic projection, if you can locate a point in 2 views, you can locate it in any view. That's true here also. So we can take an object like this and we can start tumbling it through space. Now, certainly, we are going to tumble it in certain directions that aid our needs. If you do it correctly, you'll never have a need to turn an object over 3 times. Ever. It should always be solved in 3 rotations. And in fact, when we get through chapter 14, you're going to find we actually only need to rotate twice because there will be a shortcut we introduce in there to get us out of that tertiary rotation. Now, you might say, how do I build these views? Well, I'm using these 2 to build this one. I use these 2 to build that one. I use this one and this one to build this one. Okay? We just keep stepping along this process to draw these objects. Okay? So primary, first view, rotated off of a primary view. Secondary, it's an auxiliary view rotated off of an auxiliary view. A tertiary is the third rotation. And you shouldn't have to go fast further than that. Now, besides those naming conventions, we've got some other naming conventions. There's 3 of them called the height, depth, and width that we also want to know about. Figure 13.8 across the page here shows a height auxiliary view. I believe it's height, right? No, a depth. They're doing depth first. Okay. Now, this naming convention is actually going to help you understand the dimensions you're looking at when you are looking at an auxiliary view. Okay. Now, I want to look at this guy. Let me kind of zoom in on it because I need to do a little writing on this. Okay. So here's our 3-view drawing. Keep in mind what's going on as far as dimensions, where in the front view, I have width and I have height. In this view, I've got depth and width. Now, when I turn the auxiliary view, Or in essence, this auxiliary view is being rotated off of the front view into this view. What is the only dimension missing from here? Depth, right? So when I turn and I draw this view that produces out in here, okay, that dimension right there is depth. Okay. Because I've got these two, now I'm going to rotate at 90 degrees. The only dimension that will be true in this view is the depth dimension. So we call this, any auxiliary rotated off of the front view is a depth auxiliary view, because it's the only true dimension. The other two are here in this view. You have height and width in that view, but they're kind of skewed. Okay? Because we can't draw this guy without a little bit of width and a little bit of height, right? Because it's got those two components in it. But they're skewed. Depth is true size and shape. Now, when I look at that, there's another one over here. I didn't write this one in. Is that depth? There? It is, right? So in essence, my auxiliary view is a related view to my top and right in this instance. So how do I get that depth dimension? I project from this view and this view. Now, remember, they're related. Okay, so you cannot project from here directly into here. You can't do it. Okay? Your geometry falls down. What you have to do, since they're related, is you have to project from here to here to here, or here, here to here. We always come through the adjacent view to building. You can set up meter lines on these, but they're fairly complicated, and so I would highly recommend you do not do it. In fact, I'm not even going to show you how. Okay? And we're always going to use the fold line when we start tomorrow constructing these things. Okay? So just keep in mind, even though this will be a depth auxiliary, depth is a true dimension, it is not adjacent to this guy and this guy. It's related to them. So therefore, we got to go through the front view. So any auxiliary view rotated from the front is called the depth auxiliary view. Now let's go to the next one, figure 13.9. So on figure 13.9, here they're rotating an auxiliary view off of the top view. This is kind of drawn pretty weird. This is supposed to be a front, top, should have the right here. Okay. This is the right view. That's actually front, top, bottom, whatever. This is a top view. Okay. Now, when a top view, what are the two dimensions you have in a top view? Width and depth. So if we rotate an auxiliary view off of it, what do you think we call it?
Height.
Yeah, the missing dimension, because it's going to be the only true dimension in my auxiliary view. Okay, so we're going to call it a height. So when I pull this view, like they show in the preceding steps, the height dimension will be true. That's it. The others will be there, it'll be kind of, again, a little skewed. We go from the right side. What do you think we're calling that one? Yeah, that's on the next page, figure 13.10. Here they're pulling off of a right side view. Right side has height and depth, so therefore the auxiliary view would be called the width auxiliary view, because your width will be the true dimension shown in here. Now, some other things we do with auxiliaries. These are kind of shown on 663. And I want to look at figure 13.11. When we pull an auxiliary, keep in mind that you can get a boatload of foreshortened surfaces in an auxiliary view. Because think about it. When you do a standard view like here, front and top, who picks the front view? We do. We pick it based on the fact on how it's being used in industry, and then second, difficult geometry that's easy for us to draw. So in essence, most of this object is going to be described adequately in our 6 views. The only reason we're pulling this is for that inclined or oblique view, and many times those planes, we don't have a ton of them. So in this instance, we got 1, inclined plane here. They're pulling that. If I was to do the view projection, this is true size and shape now. But all of this is foreshortened. Okay? So we're confusing the issue by giving them the whole drawing. We had a convention back in chapter 10 that allows us to clean drawings up when we get a whole mess of things. Remember what, excuse me, that one's called? What was that convention where we don't show the object in its entirety to clean it up or make it clearer? Yeah, the partial convention. Almost always with auxiliaries you will invoke the partial convention. In essence, the only reason for turning it is this plane, okay, because the rest of it's all described. Here's your short break line. We're not going to bring the rest of the object with it. Okay? We're just going to take the plane in question and describe it. So use that partial auxiliary, that partial convention. They show you another example of this on 1312. Great use of the partial convention. Here they're breaking the auxiliary view on the center line because the other half of the circle is redundant. Okay, but now we get to see that top flange and know how to construct it. As you go through here, let me just real quickly, I don't know. Let's just leave it right there. I think we covered the definitions. Okay. So just to summarize, an auxiliary view, what is it? Any view other than your standard 6. When you pull an auxiliary view, if you're coming off of the front view, you would be creating a depth auxiliary. If you're pulling off of the top view, you're creating a height. If you pull off the right side, you're creating a, I gotta think here.
Width.
That's height, but width. It's a width. Now, if you rotate off of any of those auxiliaries, okay, so I can have a primary depth, and I rotate off of that one, that would be a secondary. And then another one would be a tertiary. Last thing we need to review, inclined plane. How do you recognize it? Edge in one view foreshortened and all adjacents, right? Look at your resulting 6 views or how many ever you drew, and you should be able to find that. An oblique plane, foreshortened in all views. You know as soon as you see those two, I'm doing auxiliaries. I've got to. That's part of my job mantra. And then the last thing, dihedral angles. Any angle formed in space by the intersection of 2 planes, if we cannot see that through standard orthographic projection, we use the auxiliary view process to describe that also.
So you could have multiple auxiliary views
Yes, you could.
for each plane, incline, or oblique.
Yes. Yeah, again, everything we brought up to date so far, we can use all of that. Now we're basically giving you another drawer in your toolbox here. So whenever you see those things, you can pull it out and do it. And yes, you can have more than one. It depends on the geometry of the object.
Why do you need to go to the secondary?
Secondaries you need for dihedral angles. Okay. Inclines you're going to find are always described in a primary. Dihedrals are always described in a secondary. Obliques are always described in the tertiary.
Are dihedrals common? I mean,
Yeah, yeah, they happen quite frequently. This is a great segue into the handout I gave you. Cheryl, I'll give you $5 later.
What's that?
I'll give you $5 later. You may not have known this, but this is the process. This is chapter 14 summarized into 3 lines. Folks, this is one thing that I strongly feel is important for you to put in your memory banks verbatim. These things have been stripped down. These solve every auxiliary view problem. Here's how you do them. Now you see a bunch of words here. You don't see diagrams saying I got to turn this and this. Well, we'll get to all that, but this is the mantra of it. This is all of chapter 14 summarized. Okay? So if I've got an inclined plane, I'm doing law 1 right here. This, by the way, basic laws of descriptive geometry. What's the difference between a theory and a law? Mathematically, or I guess just as the English language uses those two words. What's a theory?
Something that has been proven.
Fact-based thing.
It's an educated
Idea.
guess, right? It's an educated guess, but you can't prove it, you don't know. Like the theory of evolution or relativity, all of these. We don't know that those happen, people have guessed. What's a law? Yeah, Amy? It's been proven, right? It happens every time. It will always work. Okay, theories fall down. Laws don't. These things right here are mathematical laws for geometry. Try and memorize them verbatim. Line appears true length in viewing plane parallel to it. That's going to solve inclined planes. That one statement right there. We'll dive into this and define all this for you. Number 2, the true length line appears as a point in the viewing plane perpendicular to it. There's your dihedral angles right there. May not make sense, but it will once we start using them. And the last one, the plane appears true size and shape in the viewing plane parallel to its edge view. Okay, that's obliques. We're going to use these repeatedly to solve these problems. I wanted to give you this early so that you can start looking at it and digesting it a little bit. We will put it in action tomorrow. Okay, so tomorrow we're going to come back into this chapter. I will probably paste a file out on your Google Classroom. We'll all upload it and make sure we can produce an auxiliary view. We'll look at the ways we do it. That's all I've got for today. This is getting good, huh? Half hour or less. Amy, thank you for the round of applause on that. Well deserved. All right, so the rest of the day is yours. Remember, you might get kind of a little bit of noise around here this afternoon. Just ignore it and keep working and doing what you're doing.